Hello, and welcome to my low-level game programming video. To begin, we will start with the memory manager. The memory manager consists of new and delete overrides, and the test will consist of creating several objects of different types on the heap, and then walking through the various heaps at different stages to show how they change. So we create a series of objects and output the size of each heap after the creation. We then walk through the default heap for the test, which is the memory manager's default, and it has 5 objects in it of varying sizes. We then delete the int val list, which should be on that default heap, and we show that the heap has reduced in size and has 1 less thing in it. We then walk the other 2 heaps to show what's in them. We then delete all of the remaining objects and show that the heaps are now empty and the final values are all 0. Something to note is that the default heap starts with a value of 152 bytes. This is due to values like the heap manager that are on the default heap. Moving on to memory pools. The memory pool system is either enabled or disabled. At the moment it's disabled, and we can see that after creating a series of objects and deleting the third one, when we create a new object, it does not use the same memory address. It instead creates a different memory address. Now we've switched over to having memory pools enabled. Same system, except we can see that when we create object 6, it takes the same memory address that object 3 had before we deleted it, showing that it's reusing the memory, so it's reducing the amount of allocations we are performing. Here we have a basic threading test. This outputs a value every second, and this test is just to show that we've got 2 threads running simultaneously without the output being corrupted, which we used a lock to make sure that that didn't happen. The ray tracer. The ray tracer is fairly complex, but we'll start with a simple single frame animation, which is basically just a static image. It took 2.5 seconds to render. This is with threading enabled. Threading in this case meaning that it renders each frame on a separate thread. So for a single frame, not much change, except for the slight overhead of managing a thread. You can see that it clears up the memory manager stuff, so all the heaps are empty at the end, and it has generated an image called Sphere 0. This is the Sphere 0 image. Like I said, it's static, but you can see that it's got several spheres in it, all with varying properties. This clip shows the rendering of a 125 frame animation. This uses threading. This is using 20 threads, which is the optimal number that I found in my testing. And you can see that the order is not necessarily consistent because of the asynchronous nature of threading. And this took 40.5 seconds to render the 125 frame animation. The program also automatically compiles the animation into a video, which is this. So for this animation, it simply changes colors and it loops. Linux port. I chose to port my application to Linux, so here I've got a Ubuntu OS running in a virtual machine, and I'm rendering a 100 frame animation, and as you can see it is compiled and running. I'm using Visual Studio Code to do this. I had to make several changes to the application to make Linux work. These are explained in the report. And here is the animation we generated. It's a simple moving sphere that gets slightly closer and bigger, and it loops as well. Here are a couple of other animations and static images I created. Here we have one of a sphere getting bigger and changing colour as it gets closer. And here we have an image that was generated using the Optree system. There is no visible difference between using the Optree system and generating normally.